In this video we are going to learn about open and close intervals. Open and close intervals have something to do with inequality, so we'll first begin with this, and I tried my best to explain what are open and close intervals. They are basically signs to signify signify an portion of a number line or a portion of any scale. Open and close intervals come in very handy. So let's begin. There is a which is less than x, and sorry there is a, okay, yes, which is less than x, and x which is less than b. It is actually said as x greater than a and less than b. It is an inequality. These two are signs of inequality. The way to represent this in signs is x belongs to a comma b. This is a sign of an open interval. Open interval. This curved bracket is a sign of an open interval. And to explain this, let's say x is greater than 1 and less than 2. So to show it with brackets, to the way open and close intervals are shown, we're going to write x belongs to 1 comma 2, and this sign is belongs to. This is a sign belongs to. This again, these are open interval, and again open interval. Now this shows that 1 and 2, x lies between 1 and 2, and 1 and 2 are not included. Means the value of x cannot be 1 and 2, but it can be anything between 1 and 2. So, and this is called an open interval, and also more specifically open interval. Now we go to open and close interval. Not open and close, open close interval, written as like this. So in this one we will say x is greater than 1 and less than equal to 2. This is the equal to sign, but as this is an inequality, so this is less than equal to 2. So it will be written as x belongs to 1, because this corresponds to this. You'll get all this by the end of this video. This corresponds to this. X belongs to 1 comma 2, and now you see that this sign A11, this sign corresponds to this sign. Okay, so this means that x has the value between 1 and 2, and it can also have the value 2, between 1 and 2, and also the value 2. This is the open close interval. Now the closed open. we say x is greater than equal to 1, greater than equal to 1 and less than 2. So in this one we write it as x belongs to 1 comma 2. Here we again see that the sign this again corresponds to this. Basically the equal to sign attached to the inequality gives us the closed bracket. The closed bracket means that it also contains the value which it is signed against. This means that x has the value 1 and anything between 1 and 2 but not 2, because this is a curved bracket and this is a square bracket, and this means that x has the value 1 and anything between 1 and 2 but not 2. And now we come to closed interval. This means if we have x greater than 1 less than equal x greater than equal to 1 and less than equal to 2, this will be written as x belongs to 1 comma 2, and this statement means that x has the value 1 and 2 and also anything between 1 and 2, has the value 1 and 2 and also anything between 1 and 2. And now we get an additional concept here. Some people may have a doubt like this, that what does this bracket mean? What does this bracket mean? We have seen this bracket. So what does this bracket mean? This bracket means a singleton set. This signifies a singleton set. A singleton set. If I say that x belongs to 1 comma 2, this means that x has the value only 1 and 2 and nothing else. This is what these brackets mean. It's called singleton set. Not the singleton set. I may have said the wrong word, but these brackets mean that x has the value only and only 1 and 2 and nothing else. Thank you. That's all with this video. This is the sign of infinity. The signs. The sleeping 8. This is the sign of infinity. And many times during solving inequalities we arrive at answers which has this as a part, infinity. So to represent this on the number line and also in the open and closed interval notations, not notation, signs, if our answer is like this, 2 till infinity, from 2 to infinity, we never use this sign. We never close infinity. It is always to be kept open, no matter what. If we close infinity, it gives the impression that we know what infinity is. As we do not know infinity, infinity cannot be closed, and this is always wrong. We should never close infinity, and this is the correct one. We should keep infinity open. And to show it on the number line, we have to show it like this, that is 2, 3, 4, and is the number line, it goes this side to the negative and the positive direction. And if our answer is 2, from 2 to infinity, oh sorry, this looks like a close one, from 2 to infinity, as this is a square bracket, this is closed, so we put a filled, a big dot, which is a sign that the 2 is included until infinity. So we mark the number line like this to infinity. Infinity cannot be shown simply. Infinity cannot be shown. It has to be shown by this arrow. If our answer would have been in some other case, like this, like neither 2 is included nor infinity is included, so we again make the number line 2, 3, 4, and then it goes in both directions. And as it goes in both directions, we cannot include 2 this time, so we put 1 minute. We put a circle. This time we put a circle which is not filled. We put this circle, and again, as the number line between 2 and infinity is the desired answer, is a answer arrived at, we darken this part again till infinity, but we keep this 2 like this to show that the 2 is not included. Here the 2 was included, so this was a filled circle, like we make a circle and then we fill it, just like that. But this time we only make the circle to show that the 2 is not included. And anyway, the infinity has nothing to do with this or this, it only has to be shown with an arrow, because we have to show that we do not know what infinity is. So this is the second part of the open and close interval, how to show and not to show infinity, and how to show it on the number line. Again, if our answer is from 2 to 8, like this, 2, 3, 4, 5, 6, 7, 8, I'm not making it properly, but this time we have to show filled circles on both sides and darken this part like before. This is our answer. I am not being able to draw it properly, but you know what I mean. This is the way it has to be shown. Now if there is a case where the answer is 2 to 5, both included, but not 3. This is a no, 1 minute. If the answer is x belongs to x, this is belongs to 2 to 5, and x does not belong to 3. The only a way to show, how we exclude one digit or one number from an interval, we again make this 2 to 5, 2, 3, 4, 5, and on 3 we have the circle, the unfilled circle. And again, if this whole is for one answer or one notation, we again, this is the way it has to be shown. So that's all for the second part of open and close intervals.